Some animals don't need teeth to be deadly. Because the real danger starts after the mouth opens. Picture this. One bird's tongue turns dark and grows backward-facing spikes, like tiny hooks that grab and refuse to let go. Yeah, a tongue that acts like a trap. Another bird has no teeth at all, yet its tongue grips like a living saw, holding food so tight it looks unfair. And it gets weirder. Some tongues are soft brushes made to steal sweet liquid in seconds, while others don't even look like flesh, more like a chain hidden inside the mouth. There's a parrot that doesn't just bite. Its tongue actually helps crack nuts tougher than bone. One creature survives with no bite, no claws, no drama. Just a tongue so long, it can erase an entire insect city. Another predator has a tongue that can scrape meat straight off bone like sandpaper. Brutal. And in the ocean, there's a tongue that doesn't taste food. It fires venom. Others strike faster than your eyes can track, or pretend to be food just to pull prey closer. Nasty little trick. All right. Keep your mouth closed if you're squeamish. Let's dive in. 20. Lorikeet. The lorikeet's tongue looks soft, but it is highly specialized and powerful for its job. The tip of the tongue is covered with hundreds of tiny brush-like fibers called papillae. This tongue evolved because lorikeets feed mainly on nectar and pollen, not seeds. Liquid food drains fast, so a smooth tongue would waste energy. When the lorikeet sticks its tongue into a flower, the brush spreads out and soaks up nectar while trapping pollen grains at the same time. Studies of feeding behavior show a lorikeet can make several licks per second, collecting more food with each movement than most birds. The tongue's function is rapid intake and trapping, not chewing. This design also turns the bird into a strong pollinator, spreading pollen between flowers. Close-up footage of lorikeet tongues has appeared in BBC Earth and viral slow-motion videos because the tongue looks more like a tool than part of an animal. If you like this video so far, leave a like, and you can also check out This Animal's Tongue Can Rip Your Skin Off on our channel for Evergreen. 19. Hawk. A hawk's tongue is short, firm, and not very flexible, but it plays a key role in a dangerous swallowing system. Hawks eat meat in large chunks and often feed quickly before other predators arrive. The tongue developed this way because hawks do not chew food. Instead, it pushes meat backward into a throat lined with sharp, backward-facing spines. These spines extend from the back of the tongue into the throat, all pointing toward the stomach. Once food moves past the tongue, it cannot come back out. Anatomical studies of raptors show that this design allows hawks to swallow prey pieces within seconds, reducing the time they remain on the ground. The tongue's main function is guiding and positioning food, not tasting or tearing. This system allows hawks to feed efficiently after a hunt while maintaining control over slippery or struggling prey. 18. Giant anteater. The giant anteater's tongue is long, thin, and extremely sticky, and it is the most dangerous tool this animal has. The tongue evolved because ants and termites live deep inside nests, tunnels, and hard soil where teeth cannot reach. Instead of biting, the anteater uses its tongue as a capture tool. The tongue can extend up to 60 centimeters, almost the length of the anteater's head and neck combined. It flicks in and out up to 150 times per minute, pulling thousands of insects each time. The surface of the tongue is coated with thick saliva produced by oversized salivary glands that stretch into the chest. The tongue's function is grabbing, holding, and dragging prey out, not chewing. Anteaters have no teeth at all, so the tongue does all the work. In one day, a giant anteater can eat over 30,000 ants and termites, all taken by the tongue alone. 17. Chameleon. The chameleon's tongue is long, elastic, and built for sudden attacks. It evolved this way because chameleons survive by staying still. Moving the body would expose them to predators and scare prey away. Instead, the tongue does all the work. Research published by scientists at Brown University showed that a chameleon's tongue can extend up to twice its body length and launch in less than 0.1 seconds. The same study measured tongue acceleration at over 40 G, which is stronger than what fighter pilots experience during takeoff. The tip of the tongue forms a sticky suction pad made of thick mucus that spreads on impact, increasing grip. This design allows chameleons to hunt insects while staying hidden. High-speed footage of chameleon tongues has appeared in BBC nature documentaries and viral science videos, often surprising viewers who underestimate how powerful this tongue really is. 16. Alligator snapping turtle. The alligator snapping turtle's tongue looks like a living worm. This is not an accident. The turtle developed this tongue because it hunts in muddy rivers where chasing prey would waste energy. Instead of moving, it lies still with its mouth wide open. The tongue has a fleshy, worm-shaped tip that wriggles on its own. Fish see the movement and swim closer, thinking it is food. When prey enters the mouth, the turtle snaps shut with one of the strongest bite forces ever recorded in reptiles, measured at over 1,000 newtons. The tongue's function is not to grab or chew, but to lure prey directly into the kill zone. This hunting method has been studied by wildlife biologists in the southern United States and shown in Discovery Channel and BBC wildlife programs. 15. Penguin. Penguins hunt underwater, where fish are fast, smooth, and hard to hold. To survive in freezing oceans, penguins developed a tongue and throat covered with sharp, backward-pointing spines. These spines line the tongue, roof of the mouth, and throat, all pointing toward the stomach. When a fish enters the mouth, the tongue presses it forward, and the spines stop it from slipping back out. Struggling only makes escape harder. This system is so important that penguin chicks are born with these spikes, even before they hunt on their own. Scientists studying Antarctic penguins have found that this design helps adults swallow fish whole in seconds, reducing time spent vulnerable underwater. Many viral close-up images of penguin mouths shocked viewers online because the outside looks friendly, while the inside looks brutal. The tongue is not for chewing. Its role is guiding prey into a trap that only moves one way. 14. Tiger. A tiger's tongue is built like a rough tool, not a soft muscle. The surface is covered with hundreds of stiff, backward-facing hooks made of keratin, the same material found in claws. These hooks are strong enough to scrape meat directly from bone. In the wild, a tiger can eat up to 40 kilograms of meat in one feeding, especially after a large kill like a deer or wild boar. Wildlife researchers from India's Ranthambore and Sundarbans reserves have documented carcasses where tiger tongues left clean, white bone after feeding. This tongue is also used for grooming. The hooks pull out loose fur, dirt, and parasites. This rough surface is the reason zoo safety rules strictly forbid contact licking. In 2013, zookeepers in Russia publicly warned after an incident where a single tiger lick removed skin from a handler's arm. The tongue plays a major role after the hunt, helping the tiger process food quickly before scavengers arrive. 13. Red-bellied woodpecker. The red-bellied woodpecker has one of the most unusual tongues in birds. It can extend up to 10 centimeters, longer than the bird's head. When not in use, the tongue wraps around the skull and rests behind the eye, supported by a special bone system called the hyoid apparatus. This structure does more than store the tongue. Scientists studying woodpeckers at universities in the United States found that this system also helps protect the brain when the bird pecks wood at speeds of up to 20 strikes per second. The tongue itself is sticky and tipped with backward-facing barbs. After drilling into bark, the bird pushes the tongue deep into insect tunnels. The sticky surface grabs insects, while the barbs hook them firmly so they cannot escape. Nature documentaries often show insects pulled from places no beak could ever reach, all because of this hidden tongue system. Before proceeding to our next selection, we invite you to explore our video on 10 cute animals that are actually deadly. Now, back to our list. 12. Hyacinth macaw. The hyacinth macaw's tongue is thick, muscular, and slightly rough, built to work under extreme pressure. This tongue developed because the bird feeds on very hard palm nuts that most animals cannot break. Its beak is among the strongest of all parrots, measured at over 300 psi. But that strength would be dangerous and unstable without tongue control. The tongue presses nuts tightly against the lower beak, keeping them steady while the upper beak applies crushing force. This prevents the nut from slipping or shattering in the wrong direction. After the shell breaks, the tongue moves sharp fragments away from sensitive areas inside the mouth. Researchers studying macaw feeding behavior in Brazil's Pantanal region have noted that tongue placement decides whether a nut cracks cleanly or fails. Hyacinth macaws became widely known after appearing in BBC Earth documentaries and films like Rio, which highlighted their powerful beaks.
Ah, this is the life.
11. Shoebill. The shoebill looks calm when standing still, but inside its mouth is a system built to control dangerous prey. Shoebills hunt lungfish, catfish, and even young crocodiles in African swamps. These animals are strong and slippery. To deal with this, the shoebill evolved a mouth interior lined with thick, backward-facing spikes. The tongue itself is small, but it plays a guiding role. Once prey is grabbed by the beak, the tongue pushes it toward the throat, where the spikes lock it in place. Any movement from the prey forces it deeper. Wildlife researchers in Uganda and South Sudan have recorded shoebills swallowing fish nearly half their body length without losing grip. This design allows the bird to stay still and calm while the mouth does the work. Nature documentaries often describe the shoebill's mouth as prehistoric, and once you see inside, it's easy to understand why. 10. Cone snail. The cone snail's tongue is one of the most dangerous tongues on Earth. It is not soft or flexible like most tongues. Instead, it is evolved into a sharp, hollow, harpoon-like tooth, which is actually a modified tongue structure called a radula. This tongue developed because cone snails are slow and live among fast, alert prey like fish and worms. Chasing is impossible. To survive, the tongue became a weapon. When prey comes close, The cone snail fires this tongue outward in a split second, injecting venom directly into the body. The venom can paralyze a fish almost instantly, stopping escape. Some cone snail species produce venom strong enough to affect humans. Scientists have recorded more than 800 different venom compounds in cone snails, making them one of the most chemically complex animals known. Its function is attack and immobilization. Medical researchers study cone snail venom for painkillers, including drugs stronger than morphine, showing how powerful this tongue-based weapon truly is. 9. Woodpecker. The woodpecker's tongue is long, narrow, and tipped with sharp, backward-facing barbs, making it one of the most specialized tongues in birds. This tongue developed because insects hide deep inside trees, far beyond the reach of a beak. In some species, the tongue can extend up to 10 centimeters, longer than the bird's head. When not in use, it wraps around the skull and rests behind the eye, supported by a bone structure called the hyoid apparatus. This same system also helps protect the brain during pecking. The barbs hook insects, while sticky saliva holds them in place as the tongue pulls them out. High-speed studies show woodpeckers can peck up to 20 times per second, and without this tongue system, much of their food would remain unreachable. 8. Flamingo. The flamingo's tongue is thick, wide, and covered with comb-like ridges that look sharp up close. This tongue evolved because flamingos eat extremely small food, such as algae and tiny crustaceans, mixed with muddy water. A normal tongue would let most of the food escape. The flamingo feeds with, and the tongue moves back and forth like a piston, pumping water in and out of the mouth. As water is pushed out, food gets trapped against the comb-like structures on the tongue and beak. Scientists have measured this pumping action at up to 20 cycles per second, making it one of the most efficient filter systems in birds. The tongue's job is filtering and trapping, not biting. 7. Leopard seal. The leopard seal's tongue is thick, muscular, and lined with deep grooves and lobes. This tongue evolved because leopard seals eat very different foods, from large penguins to tiny krill. When hunting krill, biting each animal would waste energy. Instead, the tongue presses water and prey against the teeth, forcing water out while trapping krill inside. Scientists studying Antarctic seals found leopard seals can switch feeding styles in seconds, using the same tongue for filtering small prey and guiding larger prey deeper into the mouth. Adult leopard seals can grow over 3.5 meters long and weigh up to 600 kilograms. So losing control of food would be costly. The tongue's main function is grip, control, and filtering, depending on the prey size. This system allows the seal to feed efficiently in freezing water, where long hunts increase heat loss. 6. Puffin. Puffins hunt in cold oceans, where fish are slippery and escape easily. To survive, puffins needed a way to hold prey without stopping to swallow after each catch. Their tongue and the roof of the mouth evolved with sharp, backward-facing spines. When a fish enters the beak, the tongue presses it against these spines, locking it in place. Scientists have recorded puffins carrying 10 to 20 small fish at once in a single trip. The tongue's function is not taste. It is grip and storage. The spines prevent fish from sliding out while the bird continues hunting. This allows puffins to feed chicks efficiently without wasting energy. Close-up images of puffin mouths often surprise people because the outside looks friendly, while the inside looks built like a trap. 5. Goose. A goose's tongue looks soft at first, but it is built for force. The tongue is thick, muscular, and lined on both sides with hard, backward-facing spines made of keratin, the same material as fingernails. This tongue evolved because geese feed by pulling tough grass, roots, and water plants out of the ground. The spines solve this by gripping food and dragging it deeper, while the beak cuts and clamps. Once something is caught between the tongue and beak, pulling away becomes difficult. This is why goose bites hurt, even though geese have no teeth. Wildlife studies show geese can apply over 30 newtons of pulling force with their neck and mouth combined. The tongue's function is grip, tearing, and control. 4. Giant swallowtail caterpillar. The giant swallowtail caterpillar has one of the strangest tongues in nature, even though it is not a real tongue. When threatened, it suddenly pushes out a bright orange, forked organ from behind its head. This structure is called an osmeterium. The caterpillar developed this because it is slow, soft, and easy prey for birds and lizards. It cannot bite or sting, so it needed another way to survive. The osmeterium releases a strong chemical smell, similar to rotting fruit or vinegar, which predators dislike. The sudden color and snake-like shape also shock attackers. Studies on swallowtail caterpillars show that many birds drop them immediately after contact, and featured in National Geographic insect episodes. 3. Leatherback sea turtle. The leatherback sea turtle's tongue is one of the most disturbing in the ocean. It is long, firm, and covered with sharp, backward-pointing spines that continue from the tongue deep into the throat. This tongue developed because leatherbacks feed almost entirely on jellyfish, which are slippery and collapse easily. Without a gripping system, food would slide right back out. The spines solve this problem. When a jellyfish enters the mouth, the tongue pushes it inward, and the spines stop any backward movement. Struggling only forces the prey deeper. Scientists studying leatherbacks have found these turtles can eat their own body weight in jellyfish in a single day. This tongue and throat design has been documented in National Geographic and BBC Blue Planet, shocking many viewers because the turtle looks gentle from the outside. 2. Shingleback skink. The shingleback skink's tongue is thick, heavy, and dark blue to purple, and its appearance plays a major role in survival. This tongue developed because the skink is slow and cannot escape predators easily. Instead of running, it relies on intimidation. When threatened, the skink opens its mouth wide, hisses loudly, and displays the dark tongue. Research on predator behavior shows that sudden dark or bright mouth colors can delay attacks by 1 to 3 seconds, often enough to avoid a strike. The tongue itself is not venomous, but it supports a strong warning display. The tongue also collects chemical signals for smell, helping the skink detect food and danger. Combined with its armored scales and blunt tail, the tongue adds to the illusion of danger. Wildlife documentaries from Australia often show predators hesitating when faced with this display, proving that the tongue's appearance alone can change the outcome of an encounter. 1. Gila monster. The Gila monster's tongue is thick, forked, and always moving, and it plays a key role in how this reptile hunts and uses venom. The tongue evolved because the Gila monster is slow and lives in hot desert areas where prey is hidden underground. Chasing is not an option. The tongue constantly flicks to collect scent particles from the air and ground, then delivers them to a sensory organ in the roof of the mouth. This allows the lizard to track nests, eggs, and small animals with high accuracy. Studies show a Gila monster can follow scent trails several hours old. The danger begins after a bite. Venom glands are located in the lower jaw, not fangs. As the animal chews, venom flows into the wound. The tongue helps spread saliva and venom inside the mouth during this process. Gila monster venom can cause extreme pain, swelling, and low blood pressure. One venom compound later led to the diabetes drug exenatide, now used worldwide. That's it for today. See you next time, where nature hides danger in plain sight.